Hey guys, Miss Kulkarni here. Guess what? In this video, we will talk about some exam questions in organic chemistry. So, are you ready? Our focus is going to be on a very important compound, which is chloroethene. So, what is such a big deal about this compound? Why it is so important? Look at the name. The ending is "ene." What does that tell you? That means it is an alkene. And there is a separate video I have which talks about the real life applications of alkenes. Just to review, quick review, it is useful in food industries. Also, it is useful in making polymers. Also, there are many reactions that can be carried with chloroethene, and that plays an important role in organic synthesis. So that proves it is a very important organic compound. Let's move on to our next question. This is about drawing the structural formula for the compound. Chloroethene, what does it tell you? You have 2 carbon atoms and it's an ethene. So definitely we have a double bond. That leaves 2 more bonds for each carbon atom. And one of them is substituted by chlorine. So if I put chlorine at one position, the remaining will be hydrogen. That's it. That's our structural formula. Now we have to also draw Lewis dot structure for chloroethene. Lewis dot structures requires to take into account all the valence electrons and make sure we are using those properly. But I'm going to tell you something easy. If you already have the correct structural formula, you just need to translate single bond equals to 2 electrons which are shared, and if it's a double bond, what it is? Those are the 2 shared pair of electrons. So now it makes too simple, easy. Instead of having double bond, I'm going to put there 2 electrons shared and 2 bonds with that. Then we are going to have 1 shared pair for hydrogen. This shared pair goes with chlorine and so on. There it is. That's our Lewis dot structure for chloroethene. Moving on, we have to write down the polymer product of chloroethene. So let's write down the reaction. That's our chloroethene. And when it polymerizes, if we have n number of molecules, which are plenty of molecules, they all are going to get combined into a long chain. So the reaction product gives you a polymer with all these molecules combined together. It is always a good practice to write at least 3 units of the polymer to represent the structure. So let's begin with our first unit. Those are 2 carbon atoms. In polymer, this double bond is going to break open and is going to provide the place for adding extra bonds there. So we got a single bond between 2 carbon atoms, and I'm just going to show the bonds vertical to make sure I can draw the remaining polymer. So these are hydrogen atoms and this is the chlorine. That's our 1 unit. Combine that with second unit. So you got second unit over here, and I'm going to circle this chlorine to indicate that I got 1 unit complete. That's our second unit. And we should have 1 more unit to go. There you go. And this is going to be expanding further on both directions. So we can just put the parenthesis bracket here and put N over here. That's our polymer structure. And it is chloroethene. So the polymer is called as polyethene, or also people call it polyethylene. Now let's find out the pros and cons of polymers. Polymers are always helpful. Why they are helpful? Number 1, they are easy to obtain. They are cheap, relatively economic process. Quickly we can get those. They are consumable you can use, and you can also recycle them or you can discard them. Think about that. It is easy to clean if you want to reuse. And as you know, it can be used for household storage containers to even medical use like syringes and many other things. So that is quick way to justify that polymers are good. And what are the cons or drawbacks for all these polymers? They are often discarded after use, and they go into landfill and just is the waste of space. And if you try to burn those and destroy them, combustion will produce waste gases such as carbon dioxide, carbon monoxide, and that is an environmental hazard. And scientists are trying to use microbes for decomposition of all those polymers like plastic. But it's a long road to go, so it's good and bad. Polymers are good, and also they have some adverse effects to the environment. Now this is an interesting question. It goes back to synthetic route. How do you convert chloroethene to ethanol? And that is one of the helpful reaction, because ethanol has many applications too. As an organic chemist, you will be always constantly thinking about such conversions. If you want to end up with this product, what do you need to start with? What are the chemicals and all such things? So let me give you a hint here. We had to go through two processes, and the first one is addition and the second one is substitution, and then that ends up into alcohol from chloroethene. So let me show you what we do for the first step. That's our chloroethene, and we treat that with hydrogen. So what is it called? That we call as hydrogenation reaction. So we end up getting a saturated alkane here, or alkyl chloride rather, and then that is chloroethane or ethyl chloride. And now we take that compound chloroethane and treat with aqueous base such as sodium hydroxide. So there is that OH, which is a nucleophile, and we can get the substitution. This chlorine gets substituted by hydroxide. So what we got is ethyl alcohol or ethanol. The hydroxide here is considered as a nucleophile. So what is it called? It will be called as nucleophilic substitution. And remember, it has got two different types. And if you want to know more about that, check the video about nucleophilic substitution. So guys, we found out chloroethene is a very powerful, important compound. And how easy was it to go over the exam questions about chloroethene? I hope you guys enjoyed the video, and I will see you again in next video. Until then, bye bye.